Hello, everyone. Welcome back. I hope everyone had a wonderful Easter weekend. Stay home and stay safe. Again, my name is Ping. I'm CEO of OptiGo Networks. So thank you for joining us. With me, I have Thomas McGee, our sales engineer.
Yes.
Today's session, we will talk about the transport layer. So the second last layer or the second highest layer of the network stack. And just before we dive into it, just like other sessions, if you have questions, ask away. Use the chat box in this GoToWebinar platform and put your questions in. Natalie will fill them over to Thomas and I as we go. At the end, we have a survey. We'd love your input on it. And as always, this session is recorded. If you miss any other ones, it is available on your YouTube channel. And if you want to pass this over to anyone else, it is there for others to view. Today, again, we're talking about the TCP and UDP, particularly transport layer, and tomorrow we'll move into the highest layer and the protocol layer, talk about HTTP, HTTPS, touch a little bit on encryption and BACnet as a protocol. Then we have a few more sessions. Tomorrow, again, it's at 11:30 Pacific time and 2:30 Eastern time in the afternoon. Thomas, go ahead.
Thanks very much, Ping. So today we're going to be looking at mainly the transport layer. So we had previously been looking at our layer 3 of your OSI model, internet layer on the TCP IP model. So that would have been our kind of the route we're going to take, let's say. So it's the way we try to imagine it. If you're trying to get deliver a parcel, deliver something, you might decide which way you're going to go. The transport layer is now kind of how we're going to transport it. So is it effectively lorry or van or this sort of way. So we have TCP and UDP, which are just the different means of us just sending one information from one device to another and the kind of importance of that data. So depending on what is inside that data that we're trying to send, we might use either TCP or UDP commands or protocols. So here we have just the TCP IP layers. As you can see, transport layer, how is data exchanged? So how is it we're going to send it? So we might have different times where obviously if we're going to have uploading a file, we're trying to upload a file to a drive, we need that entire file to get onto that drive. We can't have little bits and chunks missing. So that has to be a secure connection. That has to be, have you gotten every bit of it? Have you gotten 100% of what I send? Yes, I have. Perfect. Or are we going to be sending something that's maybe it's immediate, maybe it's a value that's we're just looking to monitor at any one given time, or maybe it's like a phone call where the odd skip or the odd miss is less important than being able to keep up with what's currently being sent, as opposed to saying, stop, wait, let me go back and analyze what was said 10 seconds ago. It's not really how we're used to doing conversations. So depending on what data we are sending, it's very important to know this in order to decide which protocol we're going to end up using.
Yeah, and again, bringing it back to the example we've been using all along, using the postal office or sending a parcel. If Thomas was to order toilet paper on Amazon, the network access layer, you can think of it as, are we going to use boat? Will we use planes? Will we use cars to deliver? And often it's a combination of all of it. The internet layer, the IP layer, as Thomas just mentioned, those are the routes you're taking. Is it this road or that road? Is it I-5? Is it Broadway Street? All these things. The transport layer is now that final door. It's going from the bay door of the Amazon shipping warehouse to Thomas's front door. And then tomorrow we'll talk about a protocol, the application layer, and that's eventually that's how you're using the information. And then the term payload is what you're sending. So again, it moves all the way up from the physical layer of the gravel and the sea, all the way up to that final how you're using that payload.
Thanks, Wayne. Yep. So once again, we can just have a look here at the different what we're seeing at different layers, what sort of phrases you're hearing at different layers. So obviously, at our network access layer, we're talking about our fiber cables, wires, Ethernet, copper, and that's your RJ. You might have RJ485, RJ45, Ethernet, your different types of fiber. Move up then to our internet layer. That's where we're talking about our routes, our IPv4, IPv6 is how are we even distinguishing how we define a destination. And then here we come up here to our transport. So this is how we're going to send the information. This is UDP and our BACnet network IDs. These are where we're going to be how we're going to be sending the information about and what we're going to be doing with it. So we'll look into it, and we'll probably jump to the next slide, and I'll delve into that a bit deeper.
Just a quick note here, just keep in mind that we're trying to draw some relationship between the BACnet protocol per se, the general BACnet stack, to this. It doesn't always map perfectly, but in BACnet, if you're aware of the deep down BACnet layer, how it works, you have BACnet device IDs, and then you have your MAC address, and you still have your network address. So in some way, the TCP UDP port of the transport layer would map to your network ID.
Yeah, so TCP and UDP, what are the differences and what is the main difference between them? So the main way to probably look at the two of them is TCP is connection orientated and UDP is connectionless orientated. So the main thing we're trying to see is how, if you're going to send something out, if it's going to be a broadcast, if it's going to be one-to-many message of any sort, you're not going to be establishing a connection with each individual person that you're possibly sending it out to. In these kind of big general large messages where you're sending a number of them every couple of minutes from different devices. So if you have this, if in a sense like that where you're just sending them out, you just want to send it. If they get it, they get it. If they don't, they don't. If it's something along the lines of who is or where do I go to get this information, someone will come back to them. They're not looking to make sure that each individual device at every time is getting back. So now in the end, it's a broadcast message, just trying to just send a quick, get a speakerphone, shout it out over the neighborhood, quick, see if there's anyone around. Whereas with our connection, our TCP, our connection orientated one, we need to make sure that we are establishing a connection. We're both agreeing on the means of when we're going to send. We're both agreeing that after each section of the information, we're going to acknowledge it. We're going to send it, show that we have got it, and make sure that at the end I have the full package and I have all the information. And it's almost the time. Time isn't the concern here. Getting the complete package is the concern. Whereas UDP, time is often our concern, and keeping the flow or keeping up to date or live real-time data and stuff. A lot of the time, this is something that might be, if that's the main concern, UDP. So there's just the two advantages, the two differences. So often we're sending our emails or something like that, we might be using TCP protocols because you get a whole packet, whereas a phone call, as I said before, that'll be UDP. We want to just keep that flowing.
Just a quick note, I forgot to mention earlier on, today's session, we're talking about the transport layer. It is not absolutely necessary to have a deep understanding of this to be able to do your work. And again, I'm assuming that a large majority of people watching these webinars come from the building automation, from the building lighting system, from the building technology space. We want to introduce this concept because it's important to round out the entire network stack to have an appreciation of how things work, but not having a deep understanding of TCP UDP won't prevent you from doing a good job. So again, to keep this at a higher level, we will try to talk a little bit more about how this applies to our world. But again, the difference between them are really at the operating system layer, which in most cases we don't need to worry about.
Yeah, so TCP, our transmission control protocol, is just the one that we have for secure establishing, as we say, reliable transmission protocol. It will ask to resend something. It'll send an error message. I didn't get that. Will you send it on again? Make sure that the whole package ends up at the final destination. But obviously over time, this causes more overhead because we're not just going to send each pack at once and then forget about it. We have to make sure that we're getting messages back saying they got it, and we have to be ready to send it again if needs be, or if it doesn't get it, it will send again. Whereas with our UDP, if it's lost, it's lost, and no one's going to try and find that. So something such as FTP file transfer, that's our example of something that needs to get there, has to be fully there. We can't be uploading files and finding that we're missing sections of it, especially when we don't mind if it takes 10 minutes or an hour. So as you might know your three-way handshake. It's just a phrase with TCP as you're going to send out saying, "Are you ready to talk?" The device is going to send back a reply saying, "I am." And you're going to say, "Okay, let's start on our way." So it can be your three-way handshake is just considered you're very much agreeing. Let's send. So this is a unicast. You need two devices. It has to be the handshake. You have to have two devices agreeing to talk to one another. So that's used for unicast and one-to-one. Then for our UDP, our User Datagram Protocol, this is a connection list. It just, the way it works is there's very few error recoveries. We're not going to be saying, I missed this bit of information, even talking back too much. It's just going to become at one device, sending to another. A phone call or a public announcement system or a camera that has a live feed or something like that. You know, if you see a little flicker, we don't want to then that flicker took 2 seconds. We don't want to be 2 seconds behind. We want to get right back to the main information. So here, this can be used for unicast, multicast, and broadcast. So we can use this for any types of communication or updates. And this is one of the real advantages of UDP. And this is one of the reasons we actually predominantly tend to use UDP in BACnet, because of our broadcasts and the way traffic works is that it's all a lot short bursts, small updates. It's not huge files of information. So these can be sent around, and there's not completely often not as such as IT or somewhere it could be a lot heavier. These small ones, it can actually work that if you're sending small updates around broadcast style. This is why this is used to BACnet a lot more.
So just to explain here, those again here who are familiar with BACnet, you'd be wondering now at this point, Thomas is talking about how TCP has a connection-oriented approach where there's an acknowledgement. You're sending a packet, actually it's a window of packet, and you get an acknowledgement that the set of packets was received properly. But in BACnet, there is a concept of acknowledgement. Now, so the difference here is that in BACnet, the concept of acknowledgement is done at the protocol layer, at the BACnet layer, and not at the transport layer. So in your computer, whether it's Linux or Windows or Mac, it doesn't matter, there's a operating system. Part of the operating system, there's a network stack. If BACnet chose to use TCP, it could have relied on the network stack to handle these errors and acknowledgement. But BACnet chose many years ago to use UDP for multiple reasons. Two main reasons. One is that TCP has significantly more overhead because it does acknowledgement. It doesn't deal with very, very large, it doesn't deal with streaming type of data very well. And the second, the last but definitely not the least, is that BACnet relied a lot on broadcast, and TCP cannot handle broadcast. So therefore, BACnet chose to use BACnet over IP over UDP technically, but BACnet does have the concept of acknowledgement. So there is a concept of connections, but it does it at the protocol layer.
Thanks, Wayne. Yeah, so just to kind of put it into almost a conversation or a dialogue or so. So if we have our TCP, that's going to be our very much well established. We're definitely talking, we're on an airfield, we've got our air traffic control, and we've got our pilot who's going to, every sentence is going to be here, this is who I am, or this is air traffic control, talking to flight 123, copy. They'll say, Roger Tower, this flight, copy, and back and forth. Everything's, do you copy? Are you understanding? Hey, this is me talking to you. Are we certain about this? And just making sure that there's no confusion. Obviously, if you have a dialogue of that, it's going to be pretty clear who was saying what and how it's being said. However, the less more back and forth and two-way conversation, as many people here may know, is when there's a conversation going between a teenager and a parent, and we have the very much one-sided, or we're kind of talking, not taking in as much as they're giving out or as they're saying. So as they're just, there we go, hi, I'm home, oh my god, you never believe what happened today, this person said, and just kind of going on, and then it doesn't almost matter too much what is actually said back. We'll hear it, but we can say something different. So not to say that a device is ignoring the information that's sent to it, but it could be, it's not as much relying on what was said before or what was said previously. It's more just dealing with what's being said now or these sort of ways.
And so now you can see how, you know, services like television would use UDP. It's just bombarding, it's just sending frames, and if it loses a couple, that's when you see a pixelization on your screen. It doesn't try to recover it because it's gone, right? That frame is done and in the past. Whereas when you're downloading a file or you're bringing up a web page, missing a chunk of the web page, that's not quite right. So it will reestablish it.
So BACnet UDP, so the reason we're using UDP predominantly with BACnet So as we said, we're not actually uploading as if you're uploading big files, if you're sending big chunks of information, especially if it's IT, you can have it's very, very variable what is being sent. Whereas here we know a lot more what is being sent, what sort of messages are going between devices, and what can be expected on the network. As a result, a lot of times these are smaller, shorter, and they can work with broadcast. We're not flooding our network. We're not congesting it too much because of the type of messages and what sort of data is being sent between these devices. We can allow for this. We need all messages to be broadcasting regularly, and we do require a lot of the time for devices or for all devices on the network to be able to communicate with one another, to be able to see each other's broadcasts. So that's why we have BBMDs. So these are BACnet broadcast management devices. They'll actually almost counterintuitive to a VLAN or a subnet in the IT world. If you remember this, what we mentioned before, is actually trying to take the broadcast from one subnet or VLAN and make sure we redistribute it in another one, because for BACnet broadcast and such is very important. It's how this is designed to run. So that's why we use UDP, and that's why broadcasts are so crucial to us. So exactly, thanks very much, Ming. What the BBMD actually does is, if you were to have a firewall, as you can see on the left or in the diagram there, if we were to have a firewall and that's going to stop, or as a router, it's going to keep everything within our LAN. If you remember, we've talked about this previously, it's going to stop broadcast messages. It's going to make sure that we're not flooding, everyone's not updating everyone with unnecessary messages. However, we go to our BACnet system and this actually doesn't work for us as we need, and we require the broadcasts. So you do find that in your network, you might have devices, you want to be relatable, you want to be able to talk to each other, but they are being separated by a router whose function is to stop these. So actually there have to be more devices brought in, these new devices, BBMDs, which will actually relay or send out these messages to one another to kind of get around the problem of the router stopping it. So as you can see, the OT world and BACnet and all this coming in, UDP is kind of the way it has to go about it. It runs differently. You almost have to slightly look at it you obviously look from the angle of an OT as opposed to IT. We want these broadcast messages. This is actually what we need to be going, need to be sending. And this is why we use UDP predominantly in our networks here.
Yeah, and so just quick note, you can see how BACnet can work without BBMDs. It can work even if the broadcast messages do not propagate from one network to the other. It just means that you won't be able to rely on discovery, and you won't be able to rely on things like unconfirmed COV. You have to do polling, for example, and to keep all the messages unicast.
Then so our protocol numbers for different protocols that we will be having. So protocol number is just how we relate it, what number, obviously with everything here, things are brought down to binary, hexadecimal, and different ways of identifying things. This is just how the names are, what we're associating. So when we're using our programming or configuring anything, these are numbers that relate to what protocols can be used. So FTP, we use port number 2021, or SSH, SSH, HTTP, different means of viewing their port 80 secure, HTTP secure. We have 443, and just a number of different ones. DNS. So as we mentioned previously, if you remember DNS looking up, we're trying to find from typing in an actual name, finding what IP to go to, and then we have our BACnet. So BACnet protocol number 47808. That is, I think, the most common 47808. I believe we possibly looked it up in 1 or 2 places. I don't need that down as the only number, but it is actually numbers 47808 through 47823, I believe, but 47808 being just the first number and the most commonly used, I believe.
Yeah, and again, these are standard ports, so you can still change it. These are just the most common ports to be used, and the standard talks about those ports for BACnet, but you could use other ones if you chose to. Okay, finally, last slide is if we have now an understanding of ports, one common use of port is to scan the ports. Typically, every service, every application will be tied to a port. So again, as the last slide showed, some of the common ports are 22, 23, 80, 443, for example, 47808 if there's BACnet. You can use different tools for port scanning, whether it's for discovery. We use it sometimes for development. We want to double check that port is open. We'll scan for the port, but more often than anything is for security scanning to make sure that your application, your device, your machine, your firewall doesn't have holes you didn't expect. So you'll hear a lot about vulnerability reports, pen test, penetration test, and one of the most basic approach, basic method to penetration test is a port scan. So we get put under this as a product vendor. We have customers that will, put our products under pen test, and we get a report back. Is it normal that port 22 is open? And we may say yes. We want to keep SSH open, and they may request us to close it. One last thing here to note is just be aware a little bit on the legal and ethical implication. If you are going to run port scanning at your customer site, you probably do want permission from your customers, because unfortunately port scanning is often seen as a cybersecurity attack. And sometimes monitored and blocked by IT. So just keep that in mind. Again, if you're running it for your own sake, you want to double check that the server you put in place doesn't have ports that are open you didn't expect. Just write to your IT department, just say, hey, I'm going to run port scanning on my own device. It shouldn't be a problem. And actually, I think they would applaud you for doing that. Finally, tomorrow we have a session at 11:30, and we'll talk about protocols, which includes BACnet and encryption, HTTP, HTTPS, and other ones. Is there any questions at this point? Thank you again for joining Thomas and I. We hope this is helpful and useful, and we hope to see all of you tomorrow.
Thanks, guys. See you now.
Stay safe.